Hey guys, I'm going to go over your probability study guide. I would suggest you do the whole thing by yourself and then come back to this video when you're ready to check because I'm going to jump right in with the first section. So in this first section, we're going to look at likelihood of an event occurring, and we express likelihood as a number between 0 and 1, or with these 5 criteria: is it impossible, unlikely, even chance, likely, or certain? This first question gives the statement bills are due on the 32nd of the month. That is an impossible scenario because there is no 32nd day of any month. So that is never going to occur, 0% chance. Number 2 says it will rain if there is thunder. That doesn't happen 100% of the time, but it does happen. It happens pretty often. I would say likely. If there's a thunderstorm, usually it's storming with rain. Number 3 says scoring a touchdown will result in 6 points. That is certain. That will happen 100% of the time. But yes, I did have to Google that because I do not know much about football. Number 4 says if you do your homework, your grades will improve. I would say that's pretty likely. It's like becoming a good student if you do your work. Yeah, that's likely. It's not certain because you could do poorly on your homework. So in these first 4 examples, we aren't expressing likelihood as a number, just as a statement. Is it impossible to certain? Now for the next section where we're determining the probability of simple events, we're going to have to do some math, starting with number 5. If there are 3 different colored M&Ms, and the probability of selecting a red is 2/5, and selecting green is 1/4, then the probability of selecting the third color, white, which is what the question is asking, would be whatever is left. Altogether, those 3 possibilities are going to up to 1 whole because something has to happen. Since I'm adding these fractions together, I'm going to have to get them to a common denominator. So I look at the bottom number and I think, what's the least common multiple of 5 and 4? In this case, that's 20. Since 5 times 4 got me to 20, I have to do whatever I did to the bottom to the top. 2 times 4 is 8, so that's my equivalent fraction for 2/5. Now I'm going to look at the 1/4. 4 times 5 got me to 20, and whatever I do to the bottom, I got to do to the top to make an equivalent fraction. So 4 times 5 got me 20, 1 times 5 is 5. So 8/20 plus 5/20 plus some number out of 20 is going to get me the number of white M&Ms that I need. So I'm looking for that missing value x. That's going to get me to that 20/20 outcome, which is the same thing as 1. Remember, when I add fractions, I'm just adding what's on top. 8 plus 5 is 13. So I think 13 plus what number gets me to 20? That number is 7. So there's a 7 out of 20 chance of getting a white M&M. Number 6 says we're going to draw letters out of the word January out of a hat. We want to know the probability of getting an A. So our probability for this event will be the number of A's in the word January divided by the total number of letters in the word January. There are 2 A's in the word January, and there are a total of 7 letters in the word January. So 2 out of 7 is my probability of choosing an A. Number 7 wants to know what's the probability of choosing a girl if there are 12 girls and 8 boys in the class. Since the event we're looking for is selecting a girl, that'll be the top number of the numerator, and the bottom number will always be the total. So 12 is the top number because there's 12 girls, and 20 will be the bottom number, not 8. A lot of people would think 8, but it's not the other number, it's the total number. 12 plus 8 tells me the total number of kids in the class. So this is a correct answer, but I would always simplify when I can. I can tell that 4 goes into 12 and 20, so I would divide out a 4 from both those numbers and get an equivalent fraction of 3/5. Number 8 says a weather report says there's a 30% chance of getting rain. We want to know the probability that it does not rain. Since percent is always out of 100, the probability it does not rain is just the rest of that percent. So that means there's a 70% chance that it does not rain. Number 9 says that the numbers 1 through 12 are written on a card and placed in a bag, so I wrote those numbers out here. And we want to know the probability of selecting a number that's divisible by 3. Since there's 12 numbers in total, my bottom number is going to be 12. And let's go through and pick out the numbers that are divisible by 3, starting with 3, 6, 9, and then 12. So there's 4 numbers out of the 12. That would be a correct answer, but I would always simplify when possible. So the equivalent fraction for that is 1/3. Number 10 is asking us to find the probability of choosing an action movie or a comedy movie out of these possible movies. In total, there's 7 plus 5 plus 3 movies, so out of 15 total. And the question asks what's the probability of choosing an action, and since there are 7 action and there are 5 comedies out of the 15, we would add those together to get a total probability of 12 out of 15 for choosing the action or the comedy. An equivalent fraction for that would be 4/5, but either answer is correct. For the next 3 questions, we're going to set up proportions to make predictions about probability, starting with number 11. In this question, we're pulling beads out of a basket and we're interested in the number of green beads. I know there's a total of 6 green out of a total of 8 red plus the 6 yellow plus the 6 green to give me my total number of beads. So 20 is my bottom number since 20 is the total number of beads. Now the question tells me that the bead will be drawn from the basket and replaced 60 times. That's another total. And now that I have my proportion set up, I just cross multiply and then divide to solve. 6 times 60 is 360, divided by 20 is 18. So I could expect after 60 times the green bead to be drawn 18 of those times. Number 12 says we're drawing marbles out of a bag. We know there's a total of 100 marbles in the bag of black and white marbles, but we don't know how many are black and how many are white. We know that when the student drew these out, though, that we drew out 8 black marbles and 2 white marbles. And we're interested in the number of black marbles in the bag. So the first thing I'm going to write down is the 8 black marbles out of the total number of marbles that we sampled. So this is like our sample. And there were 10 total times. Now I'll set up my proportion, and I know that there was a total of 100 in the bag. So that number goes on the bottom, and now I've set up my proportion. I can cross multiply and then divide to solve. I can also see it's being multiplied by 10 on the bottom, so it needs to be multiplied by 10 on the top. So the best prediction for the number of black marbles is 80. Number 13, I think, is really straightforward. It tells us right away we have a fraction 3 out of 12, where 3 is the number of players that have played in previous years, and 12 is the total number of people on the team. And then later on, it tells me there's 180 kids in the league in total. I have my proportion set up, and I just cross multiply to solve. So I can expect 45 people to have played soccer before. For the next section, we're determining the theoretical and experimental probability. In number 14, we have a list of pizza choices, and we're going to find the theoretical probability of choosing a Hawaiian pizza. So I look for Hawaiian. I see that there's 3 out of a total number of the pizzas that we have. So 11 plus 7 plus 6 plus 3. That tells me the theoretical probability is 3 out of 27. That's a correct answer. You could also simplify that fraction and have it as 1/9. Either way, that is the probability of choosing a Hawaiian pizza. Number 15 is another question asking for the theoretical probability, what should happen. And the question is specifically talking about biography. So I find the number of biographies, I see 4, and I write that number as a fraction out of the total number of each book. So 3 plus 4 plus 6 plus 2. So 15, since there's 4 biographies out of the 15 total. That would be your final answer. For the next 2 questions, we're looking at the experimental probability of this event, choosing green and red marbles out of a bag. We're looking at what actually did happen. So 16 says, what's the probability of selecting a green marble? We're first going to count the number of greens. I count 7 out of the total number of draws. There are 10 draws. So the experimental probability of selecting a green marble is 7/10. 17 asks for the probability of selecting a red or green marble. So there was 7 green plus 3 more red that we drew. Out of the 10 draws is 10 out of 10 because the bag only contains green and red marbles. 10 out of 10 creates a 1, a certain event. That's a 100% chance of it occurring. The next 4 questions are all about sample space. And in number 18, we're going to create a tree diagram. So what I'm going to do is I'm going to start by looking at the first 2 choices at the pizza shop. You can get thick or thin crust. After that, you can choose to get red or white sauce. And then finally, you can get a topping. And you have 3 options for your topping: pepperoni, cheese, or vegetarian. So I'm going to use P, C, and V. So in this tree diagram, you can see that we have 12 possibilities for the pizza we could get. Number 19 says a coin is flipped and then a number cube is rolled. So what we're doing is creating a list to represent the sample space. What I'm going to start with is the coin being heads or tails. And then the options for the number cube are 1 through 6. So your list should look like this. Next, the question wants the sample space to represent the coin landing on tails and rolling an odd number. So I can immediately roll out all of these because those are all heads. Now I'm going to look at tails 1 because 1's odd, then tails 3, 3 is odd, and then tails and a 5 because those are all the odd numbers in that set. For number 20, you have a few options. You're looking at school uniforms, they can choose one from each of these categories. You could make a list, a table, or you could make a tree diagram. But I would look at the cardigan option, see that there are 2. Look at the polo option, see that there are 4. Look at the bottom option, see that there are 2. And I would multiply those numbers to get our total number of possible outcomes. No matter how you do this, you should realize that there are 16 possible outcomes. And then 21 wants another tree diagram. We got a few options. The first one is to ride the bus, walk, or carpool. And she's going to do that for Thursday and for Friday. So there are 8 possible outcomes. For the rest of the questions on the study guide, we're going to determine the probability of independent and dependent events occurring. Starting with number 22, we have 4 coins. And the question wants to know what's the probability of all the coins landing heads up. For 1 coin, the probability of landing on heads is 1 out of 2. That would be the same probability for all 4 coins, and these are independent events. So I'm just going to multiply all these together. When you multiply fractions, you multiply the numerator. 1 times 1 times 1 times 1 is 1, over multiplying the denominator. 2 times 2 is 4, times 2 is 8, times 2 is 16. So there's a 1 in 16 chance that all the coins will land heads up. For 23, we have all the letters of the alphabet written on cards and then placed into this bag, and we're going to draw things out. So the first thing we're going to do is draw out the consonants. So you need to know how many consonants there are in the alphabet. In the alphabet, there are 26 letters, and A, E, I, O, and U are the vowels. That means that you take away 5 of those, and you're left with 21 consonants. Since we're drawing out a consonant, then we're replacing it. That total number 26 is not changed, and then we're looking for the letter Z. That letter Z, it happens one time in the alphabet. Since these are both independent events and we want to know the probability that both occur, we have that and statement. We're going to multiply, and that's going to tell us that we have a total probability of 21 out of 676 that both of these things will occur. 24, we're selecting from a deck of cards. You need to know that there's 52 cards in a deck, and that total 52 will not change since the card is being replaced. Since two things are happening, I'm going to have two fractions. Both of those are expressed out of 52, the total number of cards in the deck. The question asks for the probability that the first card is black and the second card is red. So the first fraction is going to be the number of black cards in the deck. Half of them are black, so 26. And the rest of the cards are red, so the other fraction is 26. Remember, I don't add these. It's not a certain thing that the first one's going to be black and the second one's going to be red. So if you got 52 out of 52, that doesn't make any sense. You're going to want to multiply these numbers to get your total probability. If you do that, you get 676 out of 2,704. That's a fraction that can be reduced. If you were going to be smart about your multiplication, I would reduce before I even did that. If half the cards are black and half the cards are red, and I multiply those, that means that my probability of choosing a black and then a red card would be 1/4. Either way is fine. 25 says Daniel's drawing toys out of a treasure chest. There's 25 different toys, and he's going to draw out a bouncy ball. If he replaces it, that total doesn't change. He selects the bouncy ball again. What's the probability that this could occur? There's only one bouncy ball out of 25, and he's doing that twice. So 1 out of 25 times 1 out of 25 gives us a total probability of 1 out of 625. That is the total probability that that could occur. Number 26 has Derek selecting socks out of a drawer. He's looking to collect a striped sock. So the probability he collects it the first time is 2 out of the total number of socks, 6. So I'm going to go ahead and reduce that fraction right now from 2/6 to 1/3. They're equivalent fractions. I just like that one. It's easier. He's going to keep that sock out. So let's say he picked this sock. That sock is no longer in the drawer because now he's going to pick a second sock at random. There's only one sock now out of 5. He no longer has 6 socks in the drawer. There's only 5 to choose from now. Since we're looking at the probability of both these events occurring, we're going to multiply, and that's going to give us a fraction 1 out of 15. It means there's a 1 out of 15 chance that he selects a striped sock both times. 27 is another example where someone's pulling something out and not replacing it. So we're going to start by looking at Aisha pulling a lemon bar. So there's 1 lemon, so my first fraction is going to be 1 out of 10 total bars. I'm adding up the 3 plus 2 plus 1 plus 4 to get the total 10. The second bar is going to be raisins. So the second fraction is going to be about raisins. And I can see up in the problem that there are 4 raisins. Now that's not out of a 10 total because she already pulled that lemon bar out. Now there's 9 total. There's 1 less. Since we're looking for the probability of both these events occurring, we're going to multiply. 1 times 4 is 4. 10 times 9 is 90. This is a correct answer, but I can also simplify this fraction to 2 out of 45. For 28, we're spinning a spinner, and we're interested in the arrow landing on a white space and then a space with stars. So let's start by looking for the number of white spaces. I count 4 out of a total of 8 spaces possible. I know 4/8 is the same thing as 1/2, so that's the probability of landing on a white space. Now a space with stars is going to be 2/8 since there's 2 star spaces out of 8 possible. 2/8 is the same fraction as 1/4. I always like to reduce and simplify now. That way when I multiply, my multiplication is easier. 1 times 1 is 1, and 4 times 2 is 8. So that means that the probability of landing on a white space and then a space with stars is 1 out of 8. 29 is asking about the probability of choosing all navy. So a navy cardigan, a navy polo, and a navy bottom. So there's a 1/2 chance of a cardigan, a 1 in 4 chance of a polo, and then a 1 in 2 chance of the bottom. I know that 1/2 times 1/2 is 1/4. And then 1/4 times 1/4 is 1/16. So there's a 1 in 16 chance that that student is going to randomly choose a navy piece of clothing from each category. All right, guys, that's it. Let me know if you have any questions. Good luck on your test. Bye.